wanted to give you a little bit of help on the homework problems that were assigned on page 281. So let's start off with this number 2, and this is the same thing you're going to do on problems 4 and 6. The ones I gave you in class were a little more difficult than this. They're actually starting you off with some easy equations because, I don't know if you noticed this or not, but on the left side of the equation, I already have a perfect square trinomial, which can be factored as this. Okay, so in other words, if I were to write x minus 2 times x minus 2, which is what that says, x minus 2 squared, use FOIL, then I would get this trinomial. The ones I gave you in class, we did not have a perfect square trinomial set up, so this could have been any other number, maybe 5. Well, now it's no longer a perfect square trinomial, so we moved the 5 over. We filled in a number, which in this case would have been 4, to create a perfect square trinomial, and then we solve from there. But on these, I just didn't want you to be confused. On these, you already have a perfect square trinomial set up. Now, if you did go through our normal process, if you went ahead and subtracted 4 first, which is kind of like what we did in class today, let me just show you that, you'll get the same answer. But hopefully you can see that on numbers 4 and 6, that's not going to be necessary. Okay, so here's my original problem put back, and in class today we said subtract this constant. Okay, so let's do that. Alright, and then we made our quantity squared, square root of x squared, bring down the sign, 4 divided by 2. Well, notice what happens. If I square negative 2, I add 4 to both sides, I'm just back to where we started. Okay, so that's on these first 3 problems. Since they're starting off easy, you can just jump right in and factor that trinomial as a perfect square trinomial. Okay, so let's just go ahead and finish this off. At this point, we would do the square root of both sides, and the square root of 100 plus minus, so that's going to be plus minus 10. And then to finish this off, I'm going to add 2 to both sides. Okay, well, this is a little bit different too than the problems that we worked in class, because they were number plus minus radical or number plus minus a complex number, and those 2 numbers in our previous examples could not be combined. Well, here I've got 2 regular numbers that I can combine. So think of your solutions for x like this until you maybe get used to seeing this. One of my solutions will be x is 2 plus 10. The other solution will be x is 2 minus 10. So on the one hand, I have a solution, x is 12, and on the other hand, I have another solution, x is negative 8. So those are my 2 answers. I just wanted you to see how you can take this expression, since we're dealing with regular numbers, they're considered like terms, they're both integers, and we can actually do the addition and the subtraction to come up with 2 different answers. If it had been like this, for example, well, that's as far as I can go. I can't put a non-radical and a radical together as a single number answer. Okay, so we're finished with number 2. So let's try a problem out of the next section. You probably didn't have any trouble with these. So you're not really solving anything. We're just coming up with that number that would be added to really both sides if we had an equation. So just think about how you make your parentheses squared, x, and then bring down the sign. And then remember this linear coefficient is 1, so we always divide by 2. So 1 divided by 2 is 1/2. All right, so the number that we would plug in here to complete the square would be negative 1/2 squared. Negative 1/2 times itself is positive 1/4. And that's all you have to do on problems 8. We just did them raised, so number 10 and 12 will be very much like that. Okay, you just have to tell what number would be put in the blank to complete the square. Okay, now this is more like what we were doing in class today, and honestly, this is more like what you're going to do on your test. These are kind of easier problems, but on the test, you're going to have to solve quadratic equations that can't be factored, and you will need to use completing the square to do it. Okay, so here is number 14. The constant is already on the right side. So I'm ready to set up my quantity squared. Square root of x squared, bring down the minus, 3 divided by 2. Okay, the number that will be added to both sides of the equation will be negative 3/2 squared, which is positive 9/4. Okay, so my x minus 3/2 quantity squared is going to equal, we can change 4 into 16/4. Okay, so think of 16/4 plus 9/4, that's 25/4. All right, now like we normally do, we do the square root of both sides. That just gets rid of the exponent 2 on the left side. And then notice what happens here, plus minus. I'll show the radical. Okay, but these are both perfect square numbers. 25 has a perfect square root, 4 also has a perfect square root. So just taking it one more step, simplifying the square root of 25/4, we get plus minus 5/2. Okay, now this is going to be a similar situation that we had back in our first example. Remember this, where we had two numbers added and subtracted, and we were able to combine them because they were both integers. So same type of deal is going to happen here. Now these aren't integers, they're rational numbers, but they're both rational numbers. We don't have one rational number and then one radical. They're both considered to be like, and so we can combine them with addition and subtraction. All right, so let me go ahead and show adding 3/2 to both sides. All right, and so now, just like I did a minute ago, let's think of our solutions like this. Let's take these fractions added together, 3/2 plus 5/2, and then let's also take them being subtracted, 3/2 minus 5/2. All right, so over here, I've got 3/2 plus 5/2 is 8/2, and we can simplify that further because 8 divided by 2 is just 4. All right, over here, 3 minus 5 is negative 2/2, and obviously that simplifies further because negative 2 divided by 2 is negative 1. So those end up being my two real number solutions. And some people, might stop here, but if your numbers are, in this case, like, you don't have one fraction and then a complex number or a radical, then you can put them together. And we showed that here at the bottom of the screen. Okay, I thought I would just do one more. This is one of those where the constant is on the right side of the equation, but our quadratic coefficient isn't 1. So we're going to need to do a little bit of work. Dividing by 4 all the way across. So that gets c squared plus 10c over 4. We could go ahead and reduce to make the numbers a little smaller. That's 5/2 c, just reducing 10/4. And you know what? Since I'm going to be in fourths anyway, I might as well just leave this in fourths, just looking ahead. I mean, it wouldn't be wrong if you reduced, but I think for my purpose of working this problem, I'm just going to leave it all in fourths. Okay. All right. So here we go with the square root of c squared. Bring down the plus, and 10 divided by 4, 10 fourths divided by 2 is 10 eighths. Okay, but we could simplify, again, we can simplify 10 eighths because 2 goes into both, and let's just go ahead and make that 5 fourths. Okay. So hopefully you caught that. Remember, when you divide these fractions by 2, it's really just like multiplying the denominator by 2. So 10 eighths simplifies as 5 fourths. Right, and the number then that we're going to be adding to both sides of the equation to complete the square is 5 fourths squared, which is 25 sixteenths. Right, so let's go ahead and combine negative 7 fourths. If we change that into sixteenths, I'll just do that over here. Just think about it this way. We're trying to make another fraction, an equivalent fraction, that has a denominator of 16. Well, you multiplied 4 times 4 to get 16, so you got to do the numerator times 4 as well. So that's negative 28 sixteenths. Okay, so here's negative 28 sixteenths added to positive 25 sixteenths. That's negative 3 sixteenths. Very good. Okay, so we're ready to do the square root of both sides. So that is c plus 5 fourths equals plus minus, and I'm going to show the radical and then we'll simplify it. Okay, so let's show the simplified form of this. Remember how we would simplify the square root of negative 3? That's I times the square root of 3. And how we would simplify the square root of 16? That's pretty easy. That's just 4. And we are almost done. To solve for c, I need to subtract 5 fourths from both sides. And these are not like terms, so they cannot be put together. You could show them all together as one fraction all over the common denominator 4. That would be okay if you showed it like that. Either way, you're not wrong in either case. So that should be your final answer then for number 24. All right. So I think that's all I have. This problem is on a separate video. I wrote the problem down, but then I realized I have an older video already posted on Moodle. It's already worked out. So instead of working this out again, if you want to check out the answer for this one, you can just check out that other video. All right, I hope that helps you out. If you have any questions, just let me know.